like this. So let's give him a warm welcome.
Thank you. All right, well, yeah, you pretty much said it. My name is Harrison Koll. This is, Secure OT Incorporation, bringing the OT and IT environments together. But yeah, he's right. I used to program building automation systems like HMIs, PLCs, and do upgrades with them. So I'd program air handling units, heat pumps, boilers, all that fun stuff. I got my bachelor's recently at UNO, so I'm pretty proud of that. And I work at ConAgra, where I help improve ICS security and work in their SOC. So it's always a lot of fun there. So we'll get into it. We're going to talk about OT versus IT, just some of the differences and what comprises an OT system, why OT is vulnerable, and then finally how you actually incorporate your OT into your IT. So what comprises an OT system? So to quote CISA, your OT environment is your profit center in a business. That's where you make all your money, and your IT environment is a cost center. You need that 100% uptime a lot of the time in your OT environment, where you can have a server go down in an IT environment for an hour and not lose thousands or hundreds of thousands of dollars. It's less of a big deal. So OT has a lot of IT components in them, and part of that comes through SCADA systems. That's how OT will deliver the information about what's going on to your IT environment, so it becomes actionable for business personnel and all that. So you'll have things like domain controllers, PCs, switches, firewalls if you're really lucky. There's a lot of times that's not there. And then databases. So the way I'd like y'all to think about just a run-of-the-mill ICS system is kind of like the human body. So you have PLCs and RTUs. Those are kind of like your brains. But those brains will perform actions on things through the use of control loops. And your control loops contain sensors, actuators, different components, so it can actually have a physical impact on the outside world. So these are programmed to do a specific thing. They'll talk with each other and the like. So next you'll have your human-machine interfaces. This is what an actual engineer will work with in order to cause changes on that system, or to just monitor your OT system. And those will often connect back again to data historians, which contain an overall log of everything that's going on. Sometimes these are done in a combination, such as with Niagara 4, which is what I'm mostly familiar with. You'd have your HMI right next to your data historian. And so that's more brains, but it's your human brains into the environment. And then finally, you have your safety systems, or your safety instrumented systems. These help return your OT environment to a safe state if something has gone wrong. Let's say somebody forced on a pilot light in a boiler. Could cause a boiler to explode. You don't want that. Well, your safety system's going to fix it. So your PLCs and your HMIs are kind of like your brain, but if you trip and fall, your SIS, or your safety instrument system, it's like your spine. It'll catch you and make sure you don't fall completely flat on your face. So we all know that OT is vulnerable, but why is it so vulnerable? So it's kind of like Bubble Boy, except as you're integrating your IT and your OT together, your IT is shooting a whole bunch of holes in your Bubble Boy's protective costume. So it had the privilege of growing up and developing in a bubble, which is why it's so insecure in general. They focused on safety, functionality, and accessibility instead of your CIA triangle. They have their SFA triangle. So they focus on zero downtime. If you do have a patch, it'll take you months in order to get it to push through. And then sometimes that patch will break everything on your system. There's been more than one time when I've upgraded the operating system or the firmware of an EasyIO controller, only to have that controller just stop functioning the way that it did because modules would no longer be supported. So patching can actually hurt the environment. And then you also have inherently insecure protocols. I mean, there's thousands of different, OT protocols that you can get to. We all know that. And they'll say, oh, my proprietary protocol is best, but proprietary doesn't mean good. I'm sure anybody here could make their own protocol, their own network, and call it proprietary. Take you 20 minutes maybe. You'll be fine. Okay, so where can you find vulnerabilities? Well, you can check places such as, your Clarity Team 82 vulnerability dashboard, CISA, ICERT advisories, CVE details, and Dragos. Those will all contain good sources of information for different vulnerabilities for different PLCs and components to your OT systems. Another good couple of places to check are with your OT engineers and with your vendors. Because if your vendors don't know what's wrong with their own systems, you probably need a new vendor. Okay, so to incorporate your OT into your IT, you need to know what's in your environment. You need to gain visibility of what's going on in that environment. Do a traffic review so you know what your environment is actually doing compared to what you think it should be doing. You might need to change up your network architecture, and you also need to make friends with your OT engineers. They're going to be doing most of your work. And then finally, governance over that system. So first, you need to find out what's in your OT environment. So you have different scanning techniques that you can use. Use a passive scanning one compared to an active scanning to enumerate your network. And that's because how many of you have ran an Nmap scan on a network that happened to have a printer? Now, imagine that printer was instead connected to, actuators, pipes, different mechanical equipment, how chaotic that could be. But your OT will respond similarly depending on the environment. So instead, what you need to check is you need to check your HMIs and you need to check your ARP tables, those two passive methods. And I say check your HMIs because your HMIs will have a list of all of the different components that are in that system in it, because the system needs to run somehow, and that's part of the whole system's brain is the HMI, where everything reports back to. So the other place you can look is your OT engineer. Your OT engineer will know most, not all, of what's in a system. And they'll be able to kind of draw out paths of communication for you so you know how things are connected in your networks. And then after you're done with your scanning techniques, you're going to check for your network access points. You'll find a lot of rogue network access points in some IC or OT networks. And that's because, your focus is again on, safety, functionality, and availability. We don't really care how you get at those networks. They just care that they got at them and they can get in and do whatever it is they need to do. So they'll leave a lot of things open. And then you'll also need to check, of course, your wired connections as well. I've found switches in ceiling tiles just hanging around. I've also found them under floors and in electrical cabinets. There's almost no standard for where they're going to put things a lot of the time. So visibility is really important as well. So most of the time, or a lot of the time, your firewall is connected to your OT environment won't be maintained very well because you don't have a security or networking person maintaining them. It's an OT person who's maintaining them. And if your OT system doesn't have a firewall associated with its connection to the outside world, you're going to need one in order to do your segmentation, in order to keep those critical areas safe. And as far as visibility goes over your OT system, you're going to need an IDS, and you're going to need to maintain it regularly. Okay, and you have a ton of different options if that's what in order to do that. So once you have some visibility and you have a firewall, you're going to need to enable logging in that firewall. And then you're going to need to block everything that you can except what the OT engineer needs for functionality. You're going to need to block things because your vendors and OT personnel will install things on your HMIs just to get stuff to function. They'll install grayware, they'll install malware. They won't know the difference just as long as they can get their job done. So you're going to need to block stuff so you can remediate any threats. And keep note of your external and internal communications while doing so. Hopefully, in this process, you can define points of unidirectional communication so that way you can cater your firewall rules as needed. And finally, you're going to check out what protocols you're using, BACnet, ENIP, Modbus. These are some of the more common ones that you're going to find in these networks. And some of the times you can get a secure alternative, like Modbus has Modbus TLS. DNP3 has a secure version as well, which are great alternatives, but you're probably not going to be able to swap over very quickly. So just a real quick thing. If you wanted to test your OT system for whatever reason that I can't quite fathom, you have Python and Java in order to help you do this. So with Python, you have Modbus CLI, which I have an example for you there if you want to know how to use it, which will, write directly to the different coils inside of a PLC. So you can actually have an effect on the PLC directly with that. Same with init fuzz and back zero. So these are great tools to use. I suggest you use them, but use them, safely. You can make yourself an offline or virtualized OT environment at your behest. You can find those online. Then you'll improve the network model. You'll use the Purdue model. This is the industry standard so far. So that separates the network into 6 levels. Level 0 through 3 are your DMZ. This is going to be where all of your PLCs and everything go. Then the levels above that, you have different levels of, how much IT is there. You have your data historians at one level, and then going up till you have your normal IT environment. And this will help you with your segmentation, but you have to know what's there again before you start segmenting, or you're going to start, inhibiting your own OT network and OT systems. All right, and this should have been the first slide, because if you block everything, you're going to have a lot of problems, but you're going to need to make friends with your OT engineers. Your OT engineers are going to do a lot of the legwork. They're just IT people, but with different priorities is the way you could think about them. But they're going to see things a lot of black and white. There's not going to be a lot of gray, because they need to get a process done, but don't necessarily care how that process has gotten done. A terrible example is when I was doing building automation, we'd run a lot of things as admin, just to run them as admin, just so that way they'd run. So. And then you'll also need to have governance over your environment after you've started implementing these different processes, right? You're going to need jump servers and VPNs for vendors to access the network so that way they can maintain it. Those vendors are also going to be trying to install different, softwares onto your overall system. So what you're going to need to do is you're going to need to check, everything that they're installing, create a list, and then approve different software, or else they'll have software interacting with your PLCs that you're definitely not going to want long term. You're going to have malware and grayware, and then similar things such as that. So you can also define patch cycles, but that's going to be costly overall. And then you'll also want to restrict access to systems and restrict access to how people get into those systems. Because again, OT personnel, we don't care about how the job gets done, just as long as it gets done efficiently. So if you don't have governance over your systems, you're going to continue to have problems. So, yeah. Does anybody have any questions? Yes, in the back.
Harrison, it's been a long time since I've worked with SCADA systems, but it seemed like as long as the thing was running, we weren't going to touch it, we're not going to patch it. They were running 30-year-old firmware. Has that improved at all with the awareness around cybersecurity, or are you still putting in mitigations because it's not getting patched, or what's the state of patching those devices?
Well, that depends a bit on where you're working, for one, of course. Overall, I feel that different companies are getting better at patching in their patching cycles. They're also getting more security awareness, so you have the confidentiality and integrity pieces coming in more and more. They don't do everything right, but they try, and they're actually trying now. Yes?
Manufacturers are starting to take this more seriously. Not manufacturers that are using the PLCs, but the developers, Rockwell Automation, all the other types of manufacturing automation solutions.
Yes, they are starting to take it more and more seriously. So they're not 100% secure, but they're trying. So up front.
Because you kind of developed in isolation, not exposed to rapid malicious traffic, that you find that when they start receiving lots of messages they're not expecting, they'll start misbehaving or breaking down, and that you can't get them back to a functional state without wiping them and starting over and reloading all the patches and figuring out. And do the developers of those patches or of the hardware then, are they accepting of problem reports to
That depends on the vendor. When I had EasyIO, we didn't even bother telling them that it broke something. We'd either roll it back, wait till the next patch, or we'd, try to deal with it as best we can. I had one EasyIO library where, the tangent, your sine, cosine, and tangent functions just didn't work. So you had to just rebuild them in the controller. So, yeah. Okay, any more questions? Nope. Okay. Well, we're good.